Yes, so hello friends, this is the video editorial for Biweekly Contest 168. So yeah, we'll discuss all the four problems. The contest is still going on, but yeah, I was able to solve all the four problems in 24 minutes. I made a wrong answer in the question 4, which was a really stupid mistake. I just created the DBR not big enough. So yeah, we'll discuss all of this. So yeah, we can begin by starting with the question number 1. Question number 1 says it's a medium. I do think it's a bit easy, and yeah, overall also I think the all the questions in this contest were easy. Like, you didn't have to think a lot. Like, in like only the C question, a bit of logic was required on your part, but other than that, I think all of the questions were very easy. So yeah, that was my experience. You can let me know your experience of the contest. So what the first question says is, you are given a string s our length n consisting of lowercase English letters. You must perform exactly one operation by choosing any integer k such that k is between 1 to n. And what this basically means is the size of the subarray that you are going to choose. And how you are going to perform this operation is, either you can reverse the first k characters of s, or reverse the last k characters of s. Return the lexicographically smallest string that can be obtained after exactly one such operation. So the point to note here is, I don't think the question won't change if it was like you can do it, you can do at most one operation. So either you can do zero operation or one operation, but here it's mentioned that you have to perform exactly one operation. And I think we all know what the lexicographically smaller string means. If you don't know what basically it means is, let's say you are given two substrings ABC and AAC. This or rather AA even, this would be lexicographically smallest because this is the dictionary order, like which in the dictionary order which will come first. Obviously AA will come first, because if we see here, the first character matches, the second character does not match, and if the second character does not match, the string having the smaller character will be the lexicographically smaller one. So a bit of a bit history of lexicographically smaller one. So yeah, if that is true, why the question I think is very easy is because of the constraints. So you are given that n is at most 1e3, that is 1000 basically. So if n is 1e3, n square can be said as 1e6. So you can actually use n square operation. And why n square is an important term here is, if you think about this, you can actually brute force a solution in n square. So you can brute force this. What means by brute force is that for each k in 1 to n, you can find two strings s1, s2. This s1 is if you perform operation 1 on s, and this s2 is if you perform operation 2 on s with length of k. And then you just need the minimum of this, and like performing this operation will take n time, right? Like, what would these op1 and op1 function do? Like, if you put, like, op1 is basically performing operation 1 with a length of k and this string. So let's say you were performing op1 on the string a b b a c of length 3. You will reverse these first three characters, right? So you will get b b a b b a a c. And similarly, the op2 function for this same parameters a b b a c 3 would reverse the last three characters. So you will get A B C A B, if I am not wrong. So all, like, doing this is just an n square operate. Is these both of these will take n time, and you will do these operation n times here. So this loop will run n time, and for each loop you will execute n instructions. So your time complexity would be n square basically. And that is why I think this is a pretty easy question, and we can also go over the code. So yeah, let's go over the code, how I implemented this. So yeah, this was the driver function that we had to make. I stored in the parameter int n equals to s dot size, and I also created this answer string. So this answer string will basically have the answer that we are going to return. So as I said, for each k in 1 to n, I got my two strings s1 by first reversing my prefix of s for the first I characters, and reversing the suffix of s, like the last k characters, and answer equals to minimum of this. So one thing that you need to know is that this minimum is actually a very okay. So this minimum function that you use, you may, if you don't know, like, this minimum in C++ actually supports strings, vectors, like complex data structures. So this is like really overloaded. So that's why this works. So, and if you have to like do a minimum of three values, like if you want minimum of 2, 5, 10, if you write it like this, it won't work, because minimum actually accepts either one parameter or two parameters. If it is accepting one parameter, so we have to create a vector of this. If you do minimum on a vector, it basically returns the minimum value. So this will return you two. So that is what I'm doing here. Like this is like you will learn these tricks of how much like the CPP, rather this the template, or rather the bits STD supports, like all of these things. You will do this by you will learn this by doing more and more questions. So yeah, if you know this question becomes like implementing this becomes very easy. So that's why what we are doing here. Okay. The reverse prefix and reverse suffix functions are really simple. In the reverse prefix, you just reverse the first, like the first k characters, and then add the rest of the string. In the reverse suffix, you reverse the last k characters and add the front of the string. So hopefully this makes sense. Let's go to the next question. Okay. Let me take a screenshot of this. Okay, so I'll also do this. Yeah. So what this question says is, you are given two positive integers, num and sum. Positive integer n is good if it satisfies both of the following. So a positive integer n is good if it satisfies both of these criteria. The sum of digits in n should be exactly the number of digits rather. So number of digits in n has to be equal to num, and sum of digits in n has to be equal to sum. Okay. The score of a good integer n is the sum of squares of digits in n. Okay, so what we need to actually maximize is the sum of digits in n square. So this thing has to be maximized by you. Is what the question says. Like it says here. Return a string denoting the good integer n that achieves the maximum score. If there are, so why it is not asking in, like why is it asking in string is basically, if we look at the constraint here, the constraint here says that num can be very large, like it is as okay, so why is this not pen? Okay. So n is num is basically 2e5, like 2e5, and like if you're creating an integer can only have 9 digits. It cannot have 2e5. So that's why you are returning it as a string here. So hopefully this makes sense. Let me just go back. Yeah. String denoting the good integer n that achieves the maximum score. So you need to return the string that has the maximum score. If there are multiple possible strings, return the maximum one. If no such string exists, return an empty string. So what is the case that no such string will no such string will exist, and you will have to return the empty string? If you think about this, let's say uh, num is, let's say, 15, or rather let's say 25, and this, or rather num is 2 and sum is 20. Can you find any, like what is the maximum sum achievable by two digits? It is 9 and 9, right? What is the maximum that you can achieve is 80. So if we think about this, the only case that these two criteria cannot be meet together is if sum is greater than num times 9. Because you have to put num digits, and all, even if you put all of them 9, you're still not able to meet this sum criteria. So if this is true, we should return empty string. For all else case, you are at least able to create a good string. Now for the good string, you have to maximize the score. Okay. Let's say the digits that you are putting is D1, D2, D3, so on till Dn, right? So I know that this sum has to be, or rather I should do is do sum of Di should be equal to sum, and you need to maximize is sum of Di square. So this has to be maximized. How can we do this? Let's think. One thing that we need to know is that if you have some D integer is, if you break this d integer down into, let's say, d minus 1 and 1. So, like, uh, let me explain what I mean this. If, let's say, your num is 3 and your sum is 60, so how should you put, you have to create three places, right? And this, let this be d1, d2, and d3, and these d1 plus d2 plus d3 should be equal to 60. Okay, so how should you break this down such that the sum is constant and the square is maximized? So I know that, like, d1 plus d2 plus d3 should be 16. The thing that you need to know is that d square is maximal of, like, if you break this down, like if you break d down into d comma d, rather d minus 1 and 1. See, the sum is still same. Here it was d, the sum of these two are same. What about the maximum? Which has the maximum? D square, this would be d minus 1 square plus 1. So this would be d square plus 1 minus 2d plus 1. So this would be d square plus 2 minus 2d, that is d square plus 2, 1 minus d. Or rather, let's take minus 2 common. So if I take minus 2 common, this would be d minus 1. Yes, d minus 1. So my left side is d square, and this is d square. Why is there a shape? So my left side is just d square, and my right side is d square minus something. D square minus 2, d minus 1, and this quantity would be greater than 0 if d is greater than equals to 1. Right? So if this is true, then, like, d minus 1 will be greater than 0. What I mean to say is, if you break any digit down or any number down, its square would get smaller. This makes sense? So if you have, like, you have to do 16, you should do 970 and not something like an 943. So this would actually have a smaller value. You can actually, like, see this. 7 square would be 49 and 4 square plus 3 square. So here we are breaking 7 down, right? So this would be 4 square plus 3 square, that is 16 plus 9, that is 25. So yes, this is maximum. So you should never break this down. And, like, what is the maximum value of d you can put? You can put 9. That is it. So what you need to do is put as many nines as possible and then put the smaller values. And we can go over the code. It's a pretty simple code, as I said. The only case where the answer cannot exist, if sum is greater than num into 9, you should return just an empty string. Other than that, you can create an answer string of, like, num, put all of these as 0, and then go over all the indexes. If sum is greater than 9, you should put a 9, else you should put whatever is left. Like here we do, I'm saying that I am going to put a 9 here. If it's not possible to put a 9, but the maximum value that is possible, remove it from sum, and that's it. Hopefully this makes sense, and, like, the mathematical proof of this also makes sense. Let's go to the next question. Question number 3. I think this was the only question, like, I had to really think about and, like, build a bit of logic. Let's see what the question says. The question says, you're given two integers nums 1. Okay, why does it not stay on pen? You're given two integer nums 1 of length n and nums 2 of length n plus 1. Okay. So this is nums 1, let's say, and this is nums 2. This will have one extra value. Okay. You want to transform nums 1 into nums 2 using the minimum number of operations. You may perform the following operation any number of times, each time choosing an index I. Increase nums, so these are the three operations you can perform. So first operation is increasing nums 1 I, decreasing nums 1 I, and third and the last one is appending nums 1 I at the end of the array. Return the minimum number of operations needed to perform to convert nums 1 into nums 2. The first thing that should come to your mind is, after reading this question, is that this operation would have to be done one time. because see, nums1 is n and this is n plus 1. So you have to do one operation and this would then become n plus 1 steps. This makes sense. So when I read this question, I thought, okay, this is pretty simple. What we can do is just like, let's say this is 1, nums1 is 135, this is 2, 4, 6, 10. So yeah, for for changing 1 into 2, you would, let's make this 1. So yeah, for changing 1 into 2, you would need you will need one operation. For changing 3 into 4, you will need one operation. For changing this, you will get four operation. And then, so for fixing these three values, you will erase this. So 114, and for this 10, you will need one operation to add something in. And which value should you add? The value that is closest to it. So you should add 5 here. And then you will have 1 plus 5. So yeah, that makes sense. Uh, Yeah, so this makes sense. But the thing is, this question is actually a bit tricky, because what you need to see is that, okay, you are putting, you don't actually have to like see the closest value to the last one in the nums one right now, because see, the nums one will change, right? Nums one will change, as in, like, if this was 3 and 7. Yes, right now the closest value is 5, but this 3 will actually get changed to 7, and then this 7 has should be appended at the end. So what I mean by this is, like, the order you should do your operations is you should, okay, so we were doing 135 and changing it to 27110, right? So the order you should do your operation is, first you should change 3 to 7, so this array would be 1 7 5, and then appending it to n. 17510, 175, sorry. Now does it make sense? Yes, if you put 5 here, you will need 5 operations. But if I put 7 here, which is not currently in my array, but it would get added to my array, then it would take 7. Okay, okay. So if, okay, I am stupid. I am doing the same thing again. Let's forget about it. So I should add 7 here. So how should you actually approach this question? Is that, okay, right? So is that, let's, if I focus on one index, so let's say I am focused on this index I, so I have to change my nums one I. Let's call the nums value as x. So this is nums one I, and this is nums two I. So let's call this x and let's call this y. And the final value, that is nums two I, let's call this t. Now see, if t is in between x and y, so I know my x will go to y. Let's for now assume that y is greater than x. So I know that my x will go to y. If t is in between x and y, then at the moment that x is t, because see, this is in between. So x at, you are doing one operation, right? It's like 3, 7, and what you need is 6. So 3 will go to 4, then it will go to 5, then it will go to 6. Now when it is at 6, you should add it at the back of the array, because that is the time that you will actually need to do zero operations. Does this make sense? If this makes sense, you can actually then f- handle the other two cases as well. If t is greater than x and y, then the minimum operation that you can do using this index is t minus 5. So if t is here, then the minimum operation is 0. If t is less than both of them, then the minimum operation is x minus 2. So this is the minimum operation to get t using I. right? So actually, your answer is sum of operation for index 0 to n minus 1 plus 1 plus minimum of operation to get nums to n, right? The plus 1 is for the appending operation, right? In the sum of operation, this thing is constant. You cannot change this based on like any choice. This thing is constant. This one is constant. The only quantity that you can change is this. And you can calculate this in n time, right? For each index, you know x, you know y, and you know based on where t lies, what would be the value of the operation needed, and you can get this thing. I will. I think the explanation of this wasn't very clear by myself, but I can show you the code. It's a pretty simple code. So all I did here is create this answer variable, and and I store the nums1.size. I go over in this last is basically the minimum number of operations that is needed to get the last value of nums2n. So initializing this as int maximum. T, as I said, is the target or the nums2 last value of n. So you go over all the you go over all the indexes from 0 to n. As I said, like let's assume mx or x, you can do anything. Mx is the minimum from x to y, so your x is getting changed to y, and my is the maximum of x comma y. If t is in between x and y, your last would become 0. Like you cannot have minimum less than 0 values. Else, if t is greater than my, so your required operation, as we saw here, was t minus y or t minus my in this case. So last would be minimum of last comma t minus my. Else last would be minimum of last comma mx minus t. So else is basically that t is less than mx, and as mx is less than my, so it would also be t is less than. So this thing is my. This is t is greater than my, greater than x. So and yeah, the operation number of operations to changing x to y would be my minus mx, and finally your return would be answer, which is just the changing from 0 to n minus 1 plus 1 to adding one operation, and which you should add, that is basically the minimum last value. So hopefully this makes sense. Let's go to the next question. I think this is a pretty like, if you have done like 20 or 30 problems of DP, you should be able to solve this. The key here is to look at the constraints. I will also show my stupid mistake that I made. So yeah. What the question says is, I was just going straight to the constraints. I should probably look at the question first. You're given an n cross n matrix of positive integer, return an integer denoting the number of ways to choose exactly one integer from each row of mat, such that the GCD of all chosen numbers is 1. Since the answer may be very large, return it 1e9 plus 7 model. What it says is, you're given a grid. Let's say the grid is 3, 5, 9, 2, 4, 3, 6, 1, 4. You have to choose like for this row one value, this row one value, this row one value. Let's say you choose this. What is the GCD of these three values? 3, 2, 1. The GCD of this is 1, right? Nothing is a common divisor between these. So this is a valid permutation. Now if you chose something like 336, the GCD of 336 is 3, so this is not valid. So you need to get the count of the valid permutations. Now let's look at the constraints. Looking at the constraints, we can see that m is at most 150, n is at most 150, and even mat ij, the value in the matrix, is 150. This is, I think, the most important constraint. This one. And why this is very important is, why this is very important is because see, GCD of a comma b is less than minimum of a comma b, right? So what is the worst case, like the biggest value that GCD can be? That is the minimum of this, like for 4 and 8, the GCD is. Why this is important is, if I know that my A and B, or rather the value of my matrix, could be at most 150, I can also say that the maximum my GCD will ever go is 150, right? So I can define a state of, or rather, if I am at index I, or at rather row I, and I know my previous state's GCD, like whatever I chose, like let's say back to this question. So I chose 3 here, then I chose 3 here. Now I am at this here. Do I need the last values? No, I only need the GCD that is currently there, like the GCD of last values. So all last values are not required. Other last values are not required. Only GCD of them is required. Is required. Why? Because see, GCD has this beautiful property that GCD of A, comma B, comma C is actually same as GCD of A, comma GCD of B, comma C. And because of this, if I know this, or rather I need to know this, I know my A and I know the previous values GCD, I can just compute this, right? So yeah. So how would my like recursive function work in record? I'm at int I'm at row I. The previous value is GCD is G. Now you go over all the choices. You get your new G as GCD of G, comma mat I J. So G is the GCD existing of all the rows from 0 to I minus 1, and you are adding this value here, and answer plus equals to record I plus 1. So what would be the time complexity here? So you can see here that you have two states, or rather two changing parameters. So you would need 2D states, and for each state, what is the transition time, or rather the number of computation you are doing n computation. So 2D state. So this is n square states basically, and for each state n time. So your time complexity is n square into n, is basically n cube. And n cube is fine. 150 cube is very less. So let's just jump over the code. I'm assuming you know what DP is. I'm assuming you know what GCD is. Like I'm not going over the basics because you're looking for solution of the D problem. So yeah. So I just basically first for the ease, like I don't want to pass my grid and my n and m, all of these parameters. So yeah, that's why I'm just storing this in global parameters. I create a DP. So this is where I made the stupid mistake. I did this. I created my DB of this and then I got a wrong answer because obviously my GCD can go as long as 150. So this has to be at most 151. I fixed this by initializing both of them as 152 just to be extra safe. It's not really needed. This size is fine, right? 150 and 151. So all I did here is you go over all the states for each state. Basically, this is the base case that if you have made the choices for all the n or for all the rows, the base case is simple that your GCD should be one. Otherwise, the all the choices were has some common GCD, so though that is not a valid state. So yeah, if this is one, you should if G is one, you should return one. You should return one. If G is not one, you should return zero. And this is basically if the state has already been seen or already been computed, you should return that answer. You go over all the choices that is possible to us. Ng is basically the new G or the new GCD for the next state. If I is 0, so the new GCD should be the grid value, because yeah, sorry. So if I is 0, the GCD would be the grid's value, else the GCD would be the all the GCDs before it, all and the GCD of this. So this is what I said. And yeah, answer equals to answer plus this. This is pretty simple. I'm sorry if I like went very fast or made the solutions like very quickly and I couldn't explain it. Stick by me, I guess. Thank you for watching. Bye bye.